even the meteorologists on the Weather Channel have a hard time, Doctor, sort of hiding their elation at what they're seeing. This baby is amazing. But then, on the other hand, they have to say, but of course it's awful and very dangerous. Get in your basements right now. So people like us, it's like riding a fine line, isn't it?
Well, that's right. And when you feel in your heart, you're very much torn apart because these events are very destructive.
Yes.
But they're extremely awesome. And if I could tell you, remember there was a earthquake in Chile about 4 years ago. It did a huge amount of destruction.
I do.
And the wave came across the Pacific. And so I went down to Hilo and stood on a cliff to watch the wave come in.
Mm-hmm.
But deep in my heart, I had this problem. I was intrigued and safe, and I knew there was hundreds of thousands of people suffering, and they were trapped in rubble.
Right.
And personally, I still have trouble dealing with that, between the elation I have for nature and the empathy that I feel for these people.
Sure.
For example, I asked a person who was the head of the earthquake studies for the United States Geological Survey. I said, the day you retire, are you going to be disappointed there hasn't been a tremendous earthquake like 1906 in California?
Right.
And he turned to me and he said, no, because of all the suffering it's going to cause. He said, I'm not sure I could actually deal with that.
And yet that's I guess the job. Right? It's a job. You should be interested in it. It's just hard to temper it so that normal people understand. That's all.
Oh, that's right. And people who deal with hurricanes, I've talked to them, and they feel the same way. There's this elation that there's a Category 5 monster out there, but they know that in 48 hours, it's going to rip across and destroy people's lives.
Again, my wife's home in the Philippines is just about the bullseye for more typhoons than you can imagine. It's horrible.
Right. In fact, here on this island, there's a tropical storm that's going to become a hurricane tomorrow, and it's projected to run very close to the Hawaiian Islands on Wednesday.
Really?
And the question is, will it go across the islands or north or south? And that's sort of what part of life of what you deal with.
Mm-hmm.
Next Thursday, my house may or may not be here.
How does it look now? I mean, I'm sure you're following the track very carefully. If the track is accurate, does it miss?
Well, it's 1,800 miles away.
Oh.
And so there's a huge uncertainty. The only thing that is certain right now is that it's going to grow from a tropical storm into a hurricane, Category 2, and it will pass close to the Hawaiian Islands at the middle of next week.
And the cone, I'm sure, at that distance is well over you right now.
On the cone includes me.
Yes,
but it could also be 500 miles north.
Mm-hmm.
So, but long ago, I just learned you accept what's given to you in terms of nature.
So Mount St. Helens is the fact that it fairly recently exploded. Does that indicate to you that it's liable to go again, or exact opposite, that it'll go to sleep for a while?
Well, a system like that can certainly go dormant for hundreds of years. It is very unlikely to have a replay of what happened in 1980. Good. And there's a variety of reasons. And so that's not, if you ask people who are involved in hazards of volcanoes in the Pacific Northwest, Mount St. Helens is there, but the bigger concerns are Shasta, Mount Hood, and Mount Rainier.
Oh.
Mount Hood, most of the watershed for Mount Hood, that's the water supply for Portland, Oregon.
Right.
Mount Rainier, because of the amount of ice on it, could produce a lot of mud flows, and they can reach the water, on the southern part of Seattle, and there's hundreds of thousands of people live there. And Shasta, Shasta, there's not as many people, but it could certainly produce a lot of destruction.
Okay.
And so those are the three which, if you ask about the Pacific Northwest, those are the ones that people focus on.
I see. All right. Well, unlike earthquakes, volcanoes, to some degree, I believe, can be predicted. Yes?
Yes, because unlike earthquakes, as far as we can tell, earthquakes are spontaneous events. Volcanic eruptions, it's the movement of magma, and it seems that it takes hours to months for it to actually break through. And so a typical eruption, you'll have hours to months of knowing that something may or may not happen soon.
And they'll be clearing people away and that kind of thing.
That's right. Unfortunately, there'll be a lot of uncertainty. You're not certain it's going to erupt, and you're not certain exactly how large it's going to be. But there certainly will be. Now hours may not be enough to do a lot of things. But a volcano does not erupt spontaneously.
It seemed to me that when Mount St. Helens went, it was a big surprise. And then after it went, I saw pictures saying, well, they should have known because the side of the dome was getting bigger and bigger and bigger and bigger. And it was kind of a big surprise, right?
Well, I can tell you what the discussions were.
Okay.
Of people who were there. It was, how could we have been so stupid? It was so obvious in hindsight what was going to happen.
Huh.
But then as we talked about it, they said, okay, let's go back a week. What were we talking about? And it wasn't obvious at the time exactly what was going to go on. And there was this constant balance of how much do we tell people of potentially how bad it may be,
right?
As to, well, this might happen, but it's a low probability. And then we have this uncertainty. This activity could go on for a year without an eruption. And people's homes are there and their jobs are there. Are we really prepared to tell people you are out of work for a year and it may or may not erupt? And we did spend a lot of time trying to balance that out.
Well, yeah. If you tell people a mountain's going to explode, they're going to get really upset. No doubt about it.
That's right. But if you say it may not be for a year, they say, well, then why can't I go to work?
And yet apparently
it might be tomorrow.
Yeah, but in hindsight, again, it was obvious, right?
In hindsight, it was obvious. That's right.
So have we changed since then? In other words, are we making careful measurements that will be apparent to us in some way other than hindsight in the future?
We're making much better measurements.
Yay.
We have much more out there in terms of finding out about earthquakes, about the ground motion. For example, where we happen to have instruments, we're able to measure the ground if it moves just by 1/10 of an inch.
Right.
And so a great deal has happened in the last 35 years. We still understand that it's not perfect, and we're not going to be able to give out, say, next Wednesday at 8 o'clock it's going to happen.
Right.
But we are certainly in a much better situation now than we were in 1980.
All right. That's a little bit encouraging anyway, although I bet there would still be a gigantic fight if what we talked about became obvious about whether to actually announce it or not. I mean, how do those decisions get made?
Well, they get made after a lot of very heated arguments and name-calling goes on in private.
Even name-calling?
It gets personal. Oh, yes. It really gets personal.
You mean scientists actually fight with each other?
Well, I'll tell you, scientific research is a contact sport.
Yeah,
and
really?
You better have a helmet on because things will get very, very heavy sometimes.
Yes. Yes, I suppose so. I don't know whether...
The egos are big. The competition is fierce.
Yeah, that's true.
And and people are sure they're right and you're wrong.
Until you're proven right or wrong.
That's right.
Okay. Let me ask you about our Earth. And how much you know. You know, we know so little, Doctor, about what's under our feet. I know there's dirt, then you dig down for a while and you get to water that you can drink if you're lucky. But I don't know much about the Earth. Period. I don't know much about the Earth. What's in the middle of the Earth? What's next to that? It's a lot of territory to cover. How much does man really know about what he stands on?
Well, let me preface it by saying Earth is one of my favorite planets.
Oh, mine too.
It certainly is on my list of favorite planets. But you hit it on the head. We know much less about the inside of the interior of the Earth than we do about the surface of Mars, or even on the interior of the Sun. We know a surprisingly great detail of what's happening inside the Sun. The other thing is the most geologically active part of planet Earth is not on the surface. It's thousands of miles beneath our feet. The Earth is like an onion. There's a core, and that's mostly made out of iron and nickel. There's an inner core that's solid, an outer core that's liquid, and then, as you learn in grade school, the mantle that's made out of what we call just a rocky material. And actually, the most geologically active part, that is where most of the chemical changes are occurring, are actually between the core and the mantle. It's not on the surface.
And what's going on between the core and the mantle?
Well, it's the chemistry. The core right there is very hot liquid iron nickel.
Do we really know all this for sure? I mean, iron
yes.
and then okay.
It's clear that for a variety of reasons, we not only know it's iron and nickel, we also know it has a very small amount of sulfur in it, and it escapes me what else. But we're very sure it's iron nickel.
Okay, well, it's not because we've been there, because we haven't. So it must be instrumentation or magnetic measurements or what?
Yes, it's a combination. It's the magnetic field. It's on the passage of the seismic waves. It's in laboratories, people put various things together like iron nickel, and they bring them to very high pressure, and they see when is it going to melt, what minerals are formed, what's the seismic velocity,
right.
And it's pretty much clear that the core of the Earth is almost entirely iron nickel.
Absolutely fascinating stuff. Hold tight. We'll go ahead and get this out of the way. This break. Dr. Dvorak is my guest, and we're going to be talking of some really fascinating stuff. Already done it, but I'm telling you, there's a lot coming up. Welcome back, everybody. Dr. Dvorak is my guest. We're talking about earthquakes and volcanoes and soon more. There was recently... You know, I really should pay attention, I guess, to the people sending me all these questions. People live, of course, all over the place. Here's somebody from Miami who says, Art, what are the chances of that volcano in the Canary Islands off Africa erupting? I read that half the mountain might fall into the Atlantic. I remember this story, and wipe out the East Coast and the Caribbean. Doctor?
Well, that is possible. It's an active volcano out there in the Canary Islands. And part of the evolution of those volcanoes, the same as here in Hawaii, is that part of them eventually slide into the ocean, and that creates a huge wave. Such things occur over a period of 10,000 years, 100,000 years. And so the probability of it happening is very low, but it is possible.
Okay, good. Well, every now and then you get those articles in the paper, and it just... it scares the heck out of you. But an island about to, or a whole part of a mountain about to fall in the water, something that would destroy perhaps the East Coast, so it's barely possible.
That's right. It's a very small risk.
Okay. If you were to be talking to the people in California right now, up and down the San Andreas, would you tell them, relax, enjoy life? Or would you say... Hey, if I lived there, I'd move. Well, of course, you wouldn't.
I would say relax, enjoy life. You live in one of the nicest places in the world. There's so much diversity. There's so much excitement. There's so much culture there. It's one of my favorite places. San Francisco,
yeah.
Los Angeles.
I was going to say high taxes, though.
The taxes are high. Yes, they're not as high as in many parts of the world. The taxes are high, but the state just intrigues me.
All right, we just had this amazing, truly amazing thing happen as we got photographs of Pluto. Now,
oh yeah, spectacular.
Yes, in those photographs were 11,000-foot mountains. Now, you know, it's cold out there. It's far from the sun. How do you imagine, can you imagine how those 11,000-foot mountains got there?
No, I was blown away.
So was I.
This is not at all what I thought Pluto was going to be.
Right.
I look at those and I'm just struck by them. To put this in perspective, Pluto is about half the size of the moon. So it's not a very big object.
Right.
And it's extremely cold and dark out there.
Yes, it is.
And so to come upon this thing with so much geologic activity, it just blew us away.
I thought we'd get a billiard ball, and a frozen one at that.
That I agree. I thought that, and it'd have a bunch of craters on it, and we'd fly by, and people would say, "What was the big deal?" It's just that's all it is. But it's a very dynamic place, and if it has those 11,000-foot mountains, glaciers made out of nitrogen, it is possible that it has an internal ocean of water.
Mm-hmm.
And of course, as people say, wherever there's water, there could be life out there.
That's right. I was watching
really intriguing.
Yes, I was watching the NASA news conference, and some reporter in the back of the room said, "You know, I don't see what the big deal is. We have got these pictures. It's not very exciting." And the scientists looked at him on the panel like he was from another planet, literally. They said, "Oh my God! Of course it's exciting. Look at this geology."
It was completely unexpected. I don't know of anyone, and I was in that, who would have thought that this was Pluto. I really thought it was just going to be a big part of ice with some craters on it,
right?
And the surface would be billions of years old. But it's an active surface, which means the internal part of it's active, which means what's the source of the heat?
Yes,
that
sir.
Drives this geology.
ABC, just like that. You get to what's the source of the heat, and I guess you could guess radiation, possibly, or I really don't know.
But everything which we would put in will not work. It's because it's a small object, and it just shouldn't have that much heat in it. Even the radioactive stuff.
So in other words, even if you model it, you don't come up with an answer.
You just don't come up with an answer. We are missing something fundamental here, and Pluto is going to point us in a brand new direction.
Fundamental, interesting. So that whatever it is might change our whole view of planetary science?
That's right, and what's out there. Remember, Pluto is just one of maybe 10,000, 100,000 objects like that out there. And so what are those things like?
Yes, indeed. Okay, that's just
and
incredible.
In terms of, well, this looks boring to me. These well, I mean what the person said at the news conference.
Yeah.
This always goes back to that same fundamental question: are we alone? What was our origin, and so forth? When you look at a brand new world, that's still part of our history.
Well, then this added more questions than it did answers, right?
Oh, certainly. I mean, it added a lot of questions.
So, you kind of explained the dynamics going on below our feet, but there may be some stuff we don't fully grasp yet.
Oh, there are many things. There are many things which we don't understand, many things that are inconsistent. that we're desperately trying to figure out.
Okay. One other area that I want to get to, we're going to eventually take calls here, but you are a scientist, and God, I love science. I absolutely love science. I understand that I can talk to you if I wish about the multiverse or the multiverse theory. Can we talk about
sure.
that?
It'll be the big discovery of the 21st century. You
think?
Yes. And we're right on the edge of it. We may have collected data, and the telescope that I work at, I may have had observers which have collected data, and they're desperately working through it and trying to convince people that yes, the multiverse is out there. It's not mainstream science. It's not widely accepted, but people are strongly going toward that.
You work with a large telescope, as you just mentioned. So I've got to ask, on behalf of a lot of people out there, have you ever seen anything that just caused you to jump? I mean, something so weird or strange that you might not even talk about it normally?
Oh, no, I'm happy to talk about anything.
Really?
But what makes me jump, as my father says, does not make a person who's normal jump. So I'm intrigued by different things.
Yes, I think we've already established that.
Okay. Well, one of the most spectacular things we saw was the breakup of a comet. The comet started to break up into about 20 pieces one night, and I was floored by that. I remember watching a storm over a period of about a week develop and dissipate on the planet Neptune. I was really intrigued by that.
Wow.
We saw a star flare up in a nursery with stars are being born. We saw one flare up one night, and of course we look at like in the Andromeda Galaxy, and we're able to see clusters of stars that sit there, and though we haven't seen it, we certainly have a lot of evidence of the gigantic black hole that sits right at the heart of the Milky Way.
I worry a bit about black holes.
Well, why?
Well, because if we run into one or one runs into us, I don't know, it'd be a bad day.
You won't even know it happened.
Well, there is that, but there is that.
If you fell into a black hole, you wouldn't even know it happened to you.
Uh-huh. But you'd still be gone, or in another universe, possibly.
Yes. People aren't quite sure what happens once you get down at the point, but in terms of being able to sense things or to see things,
uh-huh.
you would just sort of age in a normal manner. However, people who are looking at you from outside the black hole would see you gone.
Wow.
And so you really wouldn't know what's going on here.
So you might actually not I guess in the physical sense you would die, right? You would die.
Oh, well, yes. I mean, our bodies are atoms, and that's what happens to atoms. They break up and transmute and so forth.
All right.
For Dark Matter News, I'm Leo Ashcraft. A minor earthquake has struck off the northern tip of Vancouver Island. Natural Resources Canada says a 4.7 magnitude quake hit around 5:30 on Wednesday evening. The shock originated about 175 kilometers west of Port Hardy, British Columbia. Natural Resources Canada said there were no reports of damage and that none would have been expected. The ministry said the quake was not felt. According to a new study, Washington, D.C. is slowly seeping into the earth, and it could sink another 6 inches in the next century due to subsurface land movement under the Chesapeake Bay. The research confirms twin hypotheses, both of which are worrying. The first is the tide gauges show sea level rises in the Chesapeake region are twice the global average, and that levels are rising faster than elsewhere in the East Coast. The second is that the prehistoric ice sheets in the north, which pushed up the land around D.C., are now melting, and the land in the Chesapeake region is settling back down as a result. Researchers at the University of Vermont said the sinking land under the nation's capital would exacerbate the effects of flooding caused by climate change and rising ocean waters. This would in turn threaten the region's roads, monuments, wildlife refuges, and military installations. There are numerous reports of people who saw a different-looking aircraft in the sky last night. Many from the Denver, Colorado area say they saw a stealth bomber flying over Dick's Sporting Goods in Commerce City. This was just ahead of the MLS All-Star game, and that's the aircraft they saw, which means it wasn't so stealth. It made an appearance right after the national anthem around 7:15 that evening. Quite a few local area residents caught the stealth bomber on video and photographs. You can take a look at them at darkmatternews.com. Got news tips, questions, comments, or suggestions? We'd love to hear from you. Visit us at darkmatternews.com. A mystery over a group picture. Everyone was having a good time until they noticed that they were being photobombed by a ghost. Nothing out of the ordinary seemed to be going on when the photos were taken. But when they took a closer look, that's when they said they noticed a shadowy figure peering out at them from the second-story window. Natasha Oliver and her friends were hanging out in her hometown of Wim in Shropshire, UK. Oliver told ABC News that she truly believes there is a ghost woman and her baby in that window. She and her friends freaked out after they saw the photo on her digital camera back in 2010, taken when they were hanging out on the front lawn of the unfinished home still being built at the time. Oliver said, "When we saw the ghostly figure, the boys climbed up the scaffolding to see what was up there, thinking maybe someone was watching. But there was nothing up there. There were no floorboards or anything." Though the photo was taken almost 5 years ago, Oliver said it recently got widespread attention after she commented on a Facebook post about a fake ghost picture. Though some on social media believe Oliver's photo could be photoshopped, she insisted it wasn't, and added she hopes to get in touch with professional photo analysts and paranormal experts to solve the mystery of the ghost in the window. The town of Wim, where the picture was taken, previously made headlines about reported paranormal activity in 1995 when a photographer claimed he captured an image of a little girl's ghost at the ruins of the town hall that was ravaged by a fire in 1677. Oliver concludes by saying, "I didn't believe in ghosts before, but I do now. Actually, I've converted." Fake or real? Take a look at the photos yourself and let us know what you think. darkmatternews.com. And with that, I'm Leo Ashcraft for Dark Matter News.
Back now to Dr. Dvorak. Doctor, welcome back.
Yes.
Let's stay with the multiverse for a moment. How might we actually find the evidence that, really says, yes, there are multiple universes?
Well, that's actually a different question from the multiverse.
Well, multiverse, yes, I'm sorry.
Yes. There was actually a report a few months ago of a discovery. And to put it in the scientific terms, it was a pattern in the B modes of the polarization of the magnetic field on the cosmic background radiation. What that means is that astronomers were able to see the edge of the universe, and that's radiation called a CMB, the cosmic microwave background.
Okay.
And these people said what they saw were patterns on it. And if there are patterns on it, then there's something larger than the visible universe that produced those patterns. However, as they looked at more data from other researchers, from other satellites, it was decided this was actually dust in the intergalactic region. And so all that fell apart.
Oh, you had me going, and then you crushed me.
But it was intriguing. Now, I mentioned at my observatory, I've had a group of observers there. You've certainly heard of dark energy and dark matter.
Oh, my goodness, yes.
Well, these people have started what is called dark flow, that there's a general flow to the visible universe. And let me illustrate this with an analogy.
Okay.
If you were floating in a swimming pool, and no matter where you were in the swimming pool, there's always a current going from one edge to another,
Right.
you would conclude there's something outside the swimming pool producing this current.
Probably.
Okay? Because this current is always pulling you from one side of the pool to the other.
Mm-hmm.
And you say, well, there's got to be something outside the pool. So what these people look at are large clusters of galaxies. And they claim that large clusters of galaxies, they're all moving in the same direction. And the only way for that coherent motion to happen is that there must be matter, gravitational matter, outside the visible universe pulling it. Now, this is very much on the edge. Nobody has come up with any supportive evidence. This is a very minority view, but things like this can certainly change in very short time. So that's a possible way. You might be hearing more about this concept of dark flow. Also, have you talked much about in inflation theory in astronomy?
Well, that's where everything's going away from everything, right?
That's right. But there was this burst of inflation very early on in the history. This was an idea that was first developed by Alan Guth at MIT. It has a lot of very attractive, it explains a lot of things in the universe. But if this inflation theory is correct, then there has to be a multiverse out there.
Well, I imagine
any alternative here.
Yeah, I imagine
people are desperately trying to figure out if inflation theory is correct or not. And so far, it's passed every test, but it's not definitive yet.
And I know I'm wrong, but somehow I imagine rapid inflation occurring as a result of a Big Bang.
Well, the Big Bang comes after.
Really?
Yeah. What you and I know as the Big Bang is sort of the coasting that goes on after inflation. Exactly what powers inflation isn't clear either, because we're getting down to where general relativity and quantum physics have to meet, and we still don't understand what the way to put those together. As Brian Greene at Columbia University has said many times, the physicists have been playing a con game to everybody for 100 years.
Really?
We have this theory called general relativity that explains things in a very intense gravitational field and on large scale. And then we have quantum physics that explain things on very small atomic scale. But those two things are incompatible. Those are inconsistent. We have two theories of the universe. And the universe should have only one theory. There should just be one fundamental. And until we can marry these things together, we are going to have these difficulties.
I'm going to give you a chance to try and explain something to me that I ask most people of your caliber. Quantum physics is fascinating to me, and quantum entanglement.
Oh, yes.
Boy, I'm having such a hard time with that. I'm a ham operator. I understand communications, but I don't understand how two things can act in unison no matter how far they're separated without a form of communication that we don't begin to understand.
You're exactly right. Einstein called it spooky action at a distance.
It's spooky, all right.
It's not at all intuitive, but it's the way the universe works. and to put it on a fundamental level, we now live in a world with cell phones and Xerox machines and computers, right?
Yes.
All of that came out of quantum physics.
Right.
We are now into what is known as entanglement physics. And so the technology of the 21st century, people say, is going to come out of entanglement. And exactly what's going to come out is, of course, very intriguing.
To say the least, I mean,
which are being built is the quantum computer.
Right.
And if the quantum computer, if you can actually build it, it means there are parallel universes out there. That's the only way to explain the way a quantum computer works.
Doctor, does that mean if we could build one, we could talk to another or perhaps communicate with another universe?
Well, we're not sure. We're not sure
Right,
how communication goes across that.
Right.
Or what the effect is. On the electromagnetic radiation, which everyone knows is light, might not go across, but gravity would go across. And this is why people are searching for waves in the gravity field. These would go across other dimensions, the multiverse, and so forth. And so far, all we have is circumstantial evidence for the existence of gravity waves. If we ever get concrete evidence, that's a game changer. Teleportation is a reality now, but it's only on the atomic level.
Huh.
And people are trying to see, can you actually teleport something that is macroscopic? Nobody has done it, but that's where the edge of that part of science is.
So
and that,
fascinating.
of course, changes everything in terms of our culture, our technology, and so forth.
So right now, quantum entanglement, in terms of trying to get an explanation for it, we might as well call it magic. That's how much we understand it.
It looks like magic.
Yeah.
Because it's not intuitive to us. But remember, we live in a universe that is low energy and is cold.
Mm-hmm.
And much of the multiverse is probably not like that. There's reason to think that because of the Big Bang, the part of the multiverse that we grew out of got cold and very low energy density. That's what we see out there at night. But most of the multiverse is probably not that. In fact, there's probably neither time nor space in most of the multiverse. Time and space is sort of an illusion that we see because it's cold and dark around here and low energy.
Huh. We understand so little about ourselves at these levels. My goodness.
That's right. And it comes down to the same questions people have been asking. Where am I in the universe? Am I alone out here? Where did all this stuff come from? We're still trying to answer those basic questions.
As a man of science, when confronted with religious faith, conviction, how do you find yourself coming down?
Well, whenever I teach a class, I almost always begin by asking my students to tell me something that's true. I come up with the question, how do you know something is true? And the punchline is, there are different ways of coming to truth. There are various rules that we use in science. There are various rules that we use in the court system to find out if somebody's guilty or not.
Right.
There's faith. And these are different components of culture that people are using different rules to figure out what is true and what is not. And as you grow old, what you accept will actually shift around. Mm-hmm. So people with faith, I respect them a great deal. It's only when people speak things that are inconsistent or dogmatic to me that it really rubs me raw. But I certainly respect there are different ways of pursuing truth.
Sure there are. And there's it's interesting, actually, that the current Pope seems to be kind of moving religion perhaps more toward science, ever so small steps at a time. And science sometimes moves toward, the theory of how it all began. Not in 7 days, but nobody knows. I mean, there is that instant, 1 second before the Big Bang. We have no idea what happened, right? Or do we?
Well, that's right. We have to. I forget what it is. We go down to 10 to the minus 20 seconds, and we know the physics to that point, but not before. One thing that has to be said is that as you establish truth in science, that has changed over time. What was considered a way of getting scientific truth 100 years ago is not the way that scientific truth is established today. So science, the way we do it, and the way we accept research and truth has changed over time.
All right.
So there hasn't been any absolute in science.
One more question, then I've probably got to go to the phones. But how close do you think we are to building a quantum computer? I know they're fooling around with the very basics of it right now.
Yeah, I'm very confused about the quantum computer and what it's going to take. Some people have claimed that they have built one, but most people will say no. That's not it. That's not producing what's expected of a quantum computer. I'm not sure how close. I'm sitting on the edge of my seat, reading Nature and Science magazine, and seeing if somebody actually does it. It's going to change everything. Remember, a quantum computer makes most of our life obsolete because now your credit card is not secure anymore. All that security is gone.
Right.
All the military security is gone, which is why the Pentagon's extremely interested in seeing whether a quantum computer can be built or not.
I'm worried about Windows 10. Much less a quantum.
I don't know.
computer.
I've always been a Mac guy myself.
Yes. Very quickly, I think we might have Sandra.
Yes.
Hi, Sandra. On Skype, you're on the air.
Hi there. I live in San Francisco, and I'm loving your show right now because we're almost at a year from a year ago in South Napa. There was a 6.0 earthquake, and that really scared me. And it wasn't, so big in San Francisco, but just how it knocked that city down. And I don't think the Bay Area, there's just so many new people living here. I want your guests to say, how many days we really should be prepared, because I'm a member of the Neighborhood Emergency Response Team, and they say 72 hours, but I think it's really 5 days.
If it was a big one, Doctor, how long should she prepare for?
I would say be prepared to be independent of any support for 5 days. Have enough water and food and so forth, and don't expect any communication or any help. But after 5 days, hopefully people will get to you.
Well, we're trained to be self-sufficient in the NURIT program, and we're also trained to go into buildings when we're ready to just start finding people and help evacuating people. But it's a scary thing to think that could be bigger than 6.0. So thank you.
And
thank
one
you.
Thing about, am I still there?
You're there. She's not. She hung up because something big was a truck or something was I think coming toward her.
Oh, okay. What I want to tell her. And this is something that we spend a lot of time thrashing about. If there's an earthquake, like the magnitude 6 at Napa,
right,
the probability of a larger one in 72 hours goes way up. And so if there has been some destruction and you are going to start rescuing people, be aware that the ground could start shaking at any moment.
Doctor, is there a way to know if an earthquake that you just felt is a precursor and something big is coming, or if it's just a one-off thing, don't worry about it?
No. The only thing which we can do is give a probability of something happening. For example, the probability of a World Series earthquake, like the Loma Prieta,
right,
happening over the next 3 days is like 1 out of 25,000 or something. If you have a Napa earthquake, the probability of a larger one the next 72 hours is like 1 out of 20. So it goes way up for those next day or two.
Well,
and people concerned about earthquake hazards and physics of earthquakes make a very strong point to the rescuers. Understand, if you're going into a wrecked building, this thing could collapse on you.
That's true. And it seems after earthquakes, people camp out on lawns and stuff like that for exactly that reason. They've seen so many buildings collapse, they just don't want to be inside anything.
Right. And it is best if you can if it's possible, not to stay in a building during those hours. It isn't always possible, but one has to be aware of that. Okay. And even if you get a magnitude 4 earthquake, for the next couple of hours, you don't want to be standing on a ladder painting your house or into your car fixing it. Just do something else for the next few hours.
That makes sense to me. Ladder is a bad place, definitely. And I'm on and off roofs all the time, putting up antennas, doing that sort of thing. And
right. If you feel an earthquake, don't do that for a few hours.
So when scientists say, don't worry, there's not going to be another one, and they do say that sometimes after an earthquake, I was not a precursor. They don't really know.
Well, that used to be what was said, maybe some 10, 20 years ago. But that's not what is said today.
Uh-huh.